Okay, guys, in this little wrap-up video segment, we're going to kind of revisit some of the things we saw in the first two videos, and then make sure that we have everything in the right context as we kind of move forward in this model. Okay, so to do that, there are 6 things I want to talk about in terms of comparisons between the planetary model and the quantum model. Okay, along with that, I want to give kind of an overview statement of what we're kind of dealing with here. So, first thing that we have to be okay with is that electrons act as waves and particles. Second thing we have to be okay with is that the complexity of our atom is much more complex than you probably have realized up until this point. That complexity can be daunting to us. And it's really tough if you try to visualize the actual shape and size of an atom. That's why, as chemists, we move forward. We really don't try to design the shape of the atom. Generally speaking, we know that the atom kind of has an overall spherical look to it, but we can't see it anyway. We know that we have these different orbitals, or these areas of probability, that generate these different regions in which we can find electrons. Now, because of all that complexity, we don't really want to try to draw it anymore, and we can't really draw it anymore. Okay, that's okay. Now, but we do need to know where the electrons are located. Because, and this is kind of the whole reason why we do this research and this studying, the location of the electrons and the energy levels they're in and the orbitals they're in will determine later on, when we study bonding and how chemical reactions work, those locations actually determine what types of bonds are formed and what kind of ions form and everything. So we will revisit this idea of these orbitals and the location of electrons when we start to give you the reason why certain compounds form the way they do and how certain compounds don't form the way they do. Okay, so this is very foundational kind of background knowledge for us. All right, so that's why quantum theory is kind of important in our realm of chemistry, is it provides that foundation for bonding later on this year. So let's kind of go through our stuff here as we work our way through. So first thing, where are the electrons, okay? And I'm comparing planetary to quantum because planetary is the thing that I believe my students come in with the best visual on and background knowledge in. So I want to bridge that from planetary to quantum to change your perspective. So when you leave, you now have a higher level of knowledge of that perspective, okay? So going into this, the planetary model says they're at set energy levels. Great, that's their location, they're at set energy level. The quantum model will tell us that they are in an area of probability we call an orbital, all right? That's their location, all right? Yes, those areas of probabilities have different amounts of energy to them, but that's what we're going to call them, is in these orbitals or these areas of probability for their location, okay? Now, in terms of movement, right? So the planetary model focused very much on this orbiting type of movement, using that idea of the planets around the sun. The quantum model no longer does that. So we have to really exclude this word orbit from the quantum model completely, right? In fact, the quantum model views the electron when it's not being excited acting more like a wave function, which means we really don't know the actual speed and location of either of those things in it very specifically, okay? We know where it most probably is going to be. We know kind of how fast it's moving close to the speed of light, but we don't know the exact of either one of those, okay? And the reason why is because the electron is acting more like a wave function in this idea. And that goes back to some of the stuff we talked about previously with Heisenberg and his uncertainty principle, okay? So we got this idea of location and movement. So the next thing is, what about this energy? Okay, we talked about quantized energy, and we want to make sure that we understand that both models utilize quantized energy, okay? And they both use that to locate the electrons. Just in the quantum model, it's more complex, okay, in terms of our locations. Now, the next one is, how do we view the electron, all right? In the planetary model, we only view it as a particle, and that was one of the major limitations of that model. In the quantum model, we now have opened up that door to viewing the electron as both a wave and a particle, which then explains a lot of these behaviors that we see in terms of energy levels and orbitals and those kind of things inside of our model. It also helps us with the mathematical relationships that we see in there. And I kind of apologize, but the math is actually above what I would want to get into in an introductory course at a high school level. But if you get the opportunity to go into a collegiate college class and you get the opportunity to look at the math side of this, the math actually kind of helps solidify your, not maybe understanding, but your acceptance of these kind of ideas. Now, filling pattern, okay? Because we really do need to know where are the electrons at, okay? Things that are the same, they both are going to always fill from low to high energy, okay? So you always go lowest energy to highest energy, all right? The difference here is that in the quantum model, we're going to be talking about different orbitals and how much energy they contain. And the quantum model also, we're going to find out, has overlapping regions and it has more complexity to that. Okay, we haven't gotten there yet in terms of the actual filling pattern. That's coming up next in our next virtual lesson. Is okay, now that we know all this stuff about the quantum model, how do I actually map out the electrons? That's coming next. Okay, so don't worry about that yet. Okay, and finally, visualization. So how should you try to visualize this? And the reality is, for the planetary model, we draw it like the solar system. All right, I'm not sure where my cue got way over here, but it's where it's at. For the quantum model, we really don't try to draw it, okay? Some of the stuff we saw in our previous videos, you saw dumbbell shapes and spherical shapes and these lobes and these different donut kind of looking things. Those are all great for visualization, but we never try to draw this for somebody to see, because at the end of the day, you start drawing all that stuff, they overlap each other, they get in way of each other, and it ends up looking like a big cloud, okay? And that's why most chemists that look at the electron, they call the electron sitting in the electron cloud, because it looks more like big poofy lobes of a cloud than it does anything else. So in terms of visualization, you really should, if you do the quantum model, view the region around the nucleus as just a gigantic cloud that the electrons sit in these orbitals, okay? Now, those orbitals have shapes. We call them the S, P, D, and F orbitals in those locations. And we are going to map out where they all sit, but it's going to be more of a linear map and more of a mathematical map than it is a drawing, okay? Hopefully that, guys helps you kind of clarify some stuff. As always, we can always ask more questions when we get to our in-class time. Thank you.